Good day. This is Flight Instructor Walter Barry, and we'll be reviewing the emergency procedures for a trainer aircraft today. You can find these procedures in the aircraft manual in the emergency section. In the manual, there would be an abbreviated section and an expanded detail section. You should also have a handheld checklist within reach and not in the back of the aircraft, in the back seat in your flight bag. Uh, any board or checklist items in this presentation should be committed to memory and reviewed periodically. Use the checklist after completing the memory items to confirm that all the items have been covered as you complete the most important items. Review everything and review the checklist with your instructor pilot for additional details. The Cessna 172P model was manufactured in the 1980s in Kansas. It is a round-dialed aircraft with 4 seats and has a 180 horsepower engine, a Lycoming, with a carbureted system. The engine failure below VR, rejected aborted takeoff, is the checklist you would use if you have an engine failure on takeoff. The VR represents the rotation speed of the aircraft, and that is the speed that the aircraft needs to accelerate and lift off. Some scenarios that can occur for engine failure be a drop in RPM or drop in oil pressure. Also, if you have an engine fire or a blown tire, fought on the runway, which would be a piece of metal from another aircraft that previously took off. Also, if you have the inability to control the aircraft due to high crosswinds. Another scenario would be if the aircraft is taking off and there's another aircraft landing on an adjacent runway in a lasso operation. If you reject a takeoff, you should notify the tower and traffic immediately. If possible, exit the runway as soon as you can to secure the aircraft. Otherwise, the runway will remain shut down. The checklist reads here, throttle to idle, brakes as required, and flaps up. The reason you're applying the flaps is to put the main weight of the aircraft on the tires. When you bring the mixture to idle cutoff and ignition switch off, battery master switch off, you're taking the engine to the shutdown completion. All right, here is your throttle to idle position. And you bring the flaps up, applying the brakes evenly so as you maintain longitudinal control of the aircraft on the runway. The brakes are situated on the top part of the brake pedal. Try to brake evenly so that the plane maintains directional control. Exit the runway if possible. And if there is a fire, exit the aircraft and step away from the aircraft propeller area and fuel tanks. Call the tower 911 is the other optional call area. There's your flap up position. The mixture is going to go to cutoff. Ignition switch to off. Master switch to off. There are 2 scenarios here. Either there is runway remaining or the pilot has to complete an off-field landing. When the pilot may have additional runway to land, the aircraft is pitched down to the runway. Best glide speed is the best speed that you can do that at, and avoid stalling. So you can use full flaps if you have additional runway, and complete the crosswind control if you need it. exit the runway if possible, and notify the tower and as you're exiting the aircraft. So the checklist reads here, airspeed 65, flaps 60, mixture to idle cutoff, fuel selector to off, ignition switch off, flaps is required, and master switch off. Complete the checklist. You can find this chart in the manual, and it provides distance information once the glide speed is set. So pitch inputs are important. Pitch and trim right away are required for the best glide speed. Average speed is around 60 to 65 with or without flaps, and it's based on zero wind. To secure the aircraft, the fuel valve is brought to the 6 o'clock position and down. Flaps can be used. The maximum flaps for landing would be 30 degrees. There's a mixture lever. The fuel selector goes to the off position. Ignition switch goes to off. And flaps, again, you have up to 30 degrees of flaps in the P model. Master switch off. Once you take the master switch off to the off position, your flaps cannot be extended or retracted. And brakes applied for the landing, of course. In that photo with the brakes is the newer versions of the Skyhawk. You can see that the fuel lever is a pull type. That's the red knob on the right side of the pedals. Engine failure in flight. So one scenario, the pilot has to land off the field. In flight with a engine failure, the pilot should troubleshoot his equipment. Check the fuel quantity, oil pressure, and temperature, and confirm that the magnetos are in the both position. The primer should be in the locked position, and check if the mixture was not managed correctly for the altitude. Carburetor icing can occur with high humidity and proximity to clouds or after rapid dives. Check for the landing area, and then the checklist reads airspeed 65, carburetor heat on, fuel selector to both, mixture rich, ignition switch both, primer in and locked, ignition switch start, engine gauge is complete, checklist complete. Now, if you're at very high altitudes, a leaner mixture would help in the starting. Pilots should aviate, navigate, and communicate. If the aircraft has GPS, you can go to the nearest airport and determine if you have the glide distance. The chart above is based on zero wind, so any headwind or tailwind will affect the range. Some GPS equipment, the newer equipment, provides wind information, like the G1000. If you're not within range of the airport, you will have to select a landing spot, including roads or open field. You'd have to watch out for power lines, cattle, traffic, irrigation ditches, and obstructions such as fences and trees. So there's the carburetor heat lever. This is a carbureted engine, so you do want to pull that in case you have potential ice in the carburetor venturi. Your fuel selector should be in the both 12 o'clock position. Adjust your mixture. Go to your start. Make sure your primer is locked. Check your fuel gauges, engine gauges. You may have run out of fuel. In that case, you do have to land. So if you have the engine failure in flight, if time permits, notify ATC. Your radio transponder squawk is 7700. If you're outside of the ATC communications range, you can Mayday on 121.5. That's the international Mayday frequency. You can activate the ELT in flight, brief your passengers, and secure the seatbelts. The GPS can help locate your position when you're communicating with ATC. Also, VOR radials can be centered with an off position, with the from position location will give you the location radial that you're on. The Cessna 172 shoulder harnesses are for the front pilots only. Scenarios where the pilot may want to land are varied. For example, you would be about to run out of fuel, or you're trapped by weather such as icing or thunderstorms. Mechanical failure would be another, or flutter of the flight controls, and engine failure. Pick a field position with an overfly and prepare to shut down on the downwind. Know your landing distance and avoid obstructions. Use the soft field landing technique. The checklist reads: power off landing, airspeed 65, 60, mixture idle cutoff, fuel selector off, ignition switch off, flaps as required. You can put up to 30 again with the 172. Turn the battery master switch off just prior to the landing and unlatch your doors. Seatbelts and shoulder harnesses tight. Touchdown slightly tail low. Brakes as required. And checklist complete. Based on the pilot's skill, glide distance is about 1.4 miles per 1,000 feet with a clean aircraft. With the doors open, the distance may be less. With ice accumulation, the distance will be affected as well. So here, the mixture, fuel selector to off, ignition switch to off, flaps is required for the landing. Apply your brakes on the landing. This checklist is used when there's a fire during startup. There's two scenarios, one with the engine running and the other one with the engine not running. Typically, this occurs when there's overpriming and a backfire occurs with the engine. With fire extinguishers, if you have them on board, you pull the safety pin, aim it at the base of the fire, and you squeeze the handle. The paper element is usually the area that gets affected with the fire, and the backfire can cause the paper element underneath the propeller to catch on fire. Another scenario would be a ruptured fuel line or hot engine, which can cause this. The cowling should be removed for inspection by the fire department at the field, and the mechanic should inspect it for return to service. The checklist reads: if the engine catches on fire, ignition switch continue cranking. If the engine does not start, then you're going to go full forward with the throttle and mixture to idle cutoff. Battery master switch off, ignition switch off, fuel selector off, cabin fire obtain, and exiting the aircraft, you go to the front by the paper element and discharge the fire extinguisher. If the engine does start, of course, you're going to run the RPM to 1700 for 2 minutes, and that'll consume the fuel in the line. Fuel selector off, mixture off, battery master switch off, ignition switch off, and of course you're evacuating the aircraft in both scenarios. So that first scenario, we're going to continue to crank and we're looking at 1700 RPM. Mixture, master switch. If the engine starts, then we're going to continue the start position there with the key. The throttle is going to go full forward, the mixture to the far aft, and you'll be treating that like a flooded start. Master switch off. Fuel selector to the off position. Taking your fire extinguisher and aiming at the base of the fire is important. Of course, the cowling will be on, but the paper element is exposed right under the propeller, so should that be on fire, that's the way you put it out. These fire extinguishers hold a chemical halon 1211, typically mounted in the cabin. To inspect the bottle, check the pressure gauge, and should be in the green. When you're using it, pull the safety pin and remove the clamps. Have the fire department inspect the bottle at intervals to see if it's still fully charged and not rusted on the inside. Engine fire during start, you cannot extinguish the fire, keep the passengers away from the flames, call the fire department or 911. If you call the tower, many airports have the fire department on the field. Avoid breathing smoke and fire extinguisher agent. So this scenario can occur when the radios or digital equipment on board, including electrical buses, circuit breakers, and fuses, catch on fire. Pilot can attempt to isolate the damaged unit. With the master switch off, all electrical flight plan will be lost unless saved in memory. Most units can store up to 99 flight plans. Access to the units may be difficult with the fire extinguisher. Feel for the hot to touch circuit breakers and equipment. Do not reset the circuit breaker if it's smoking or hot. Circuit breaker should be cool 2 to 3 minutes before you reset it. If they pop out again, don't reset them. The checklist reads: electrical fire in flight, smoke in the cockpit, battery master switch off, avionics off, all other switches off, vents and cabin, air heat closed, cabin fire extinguisher obtained, cabin ventilation occurs. You can pull the lever. Also, you have windows which you can open. If fire is extinguished and electrical power is needed, battery master switch back on, circuit breaker checked, isolate the radio if it's on fire. And if one is not on fire, you can use the one that's not on fire, of course. Avionics switches on, radio and electrical switches one at a time back on. Vents and cabin air heat. When fire is extinguished, open it up and land as soon as practical. So the vents and cabin air are initially closed to prevent oxygen to feed the fire. Then at the end, when you've got it under control, you open up your vents and windows. So there's your master switch, avionics switch. There's another picture of the avionics switch up close. Turn off your lights and pitot heat. Your cabin ventilation should go to the off position. That's right under the co-pilot's side. Get a hold of your fire extinguisher. Of course, the fire extinguisher may be angled to deal with the fire. Having a second airman to accomplish this, this will help you fly the aircraft and prevent the loss of aircraft altitude. There are two types of circuit breakers on the 172, or the black ones and the white ones. The black ones, you can pull an isolated component The white ones will pop out if the amperage load is exceeded. There's your master switch, avionics switch, lights, and cabin air. There's your circuit breaker panel. So if the fire is on the circuit breaker panel, the main bus bar, getting up into that from the back is difficult. So you need to land as soon as possible. Master switch would be off. Again, you feel the circuit breaker as if they're hot to the touch. Do not reset them. You can reset them once, and if they pop out again, then leave them alone. Engine fires can be identified with smoke and flames in the forward cowling area. Check the engine temperature gauge. This may indicate other issues such as loss of oil pressure. The pilot should prepare for an emergency descent by exiting the Victor airway to avoid a mid-air collision. The aircraft will be descending at about 2,000 feet per minute. Speeds controlled by pitching and trim should be used. Exceeding the green arc can be accomplished only in smooth air, wings level, going into the yellow arc, but you never want to go to the red line. Lead the level off by 10% of the VSI. So if you're descending at 2,000 feet per minute, your level off should be about 200 feet above the planned pattern altitude. If field below you should be picked out when the pilot pitches down, and then in the pattern go to glide speed for planned downwind position. Use your flaps accordingly and conservatively so you don't land short of your planned point. Turn the master switch back on momentarily if you need that for the flaps. Engine fire in flight, the mixture is idle cutoff, the fuel selector goes off, the battery master switch goes off, and cabin heat and air, you want to close that since that's brought in from the engine area, could bring in smoke. And the airspeed above 100 to try to extinguish the fire. Then when you get near the landing area, you need to go to your glide speeds for the landing. So there's your mixture to cut off. Fuel valve to the off position, 6 o'clock. Master switch off. Close the ventilation. Final line was prepare the passengers for landing and confirm the seat belts are on. Open the doors so if the hull buckles on the landing, exiting will be a problem. Exit the aircraft and step away from the aircraft. So typically we're diving at 100 knots or better. When fire is out, configure for the glide. Cabin fire in flight scenarios include smoking cigarettes and cigars in the cabin could cause this, exploding lithium battery and smartphones, vaping equipment, or navigation pads. Halon 1211 will work on upholstery, but not lithium batteries. Throw the lithium product out the window. The checklist reads cabin fire in flight, battery master switch off, vent cabin air heat closed, cabin fire extinguisher obtained, and cabin ventilate. Land as soon as practical and execute. Checklist complete. So there's your battery master switch. Close those vents. Takes oxygen from the fire. So the lithium batteries can be extremely hot to handle. Equipment available on the pilot shops and their websites, you can find some equipment that would help control that. With the fire extinguisher, again, you release the clamp, take the fire extinguisher, pull the pin, aim the nozzle at the base of the fire and squeeze the trigger, and that should put it out. Try not to breathe the halon since it can cause hypoxia. Wing fire scenarios can include flap motor. The flap motor is located in the right wing. Your lighting equipment and wires if you have a lightning strike. Also, the fuel caps on the 172 have a protective O-ring, so that O-ring is there to designed to keep out water and static electricity, and that should be inspected in your pre-flight. The checklist reads: wing fire in flight, landing, taxi lights off, pitot heat off, navigation light off, strobe lights off, side slip execute, land as soon as possible, execute, and flaps as required, checklist complete. The side slip is accomplished when the pilot lowers one wing with the aileron and uses opposite rudder. This is a cross control maneuver. So you want to aim to keep that flame away from the fuel tanks and the cockpit. There's your light switches. You're going to turn them off. That's your pitot heat as well. Scenarios where the pilot may want to land are varied. Some examples would include running out of fuel, trapped by weather such as ice and thunderstorms, mechanical failure and flutter of the flight controls, engine failure. The precautionary landing is an abnormal checklist item and has no bordered memory items. So you just take the checklist out and read it per verbatim. The flaps go to 20 degrees, airspeed 60 knots, landing area flyover, avionics switch off, electrical switches off, flaps 30 degrees, airspeed maintain 60 knots, battery master switch off, unlatch your doors prior to the touchdown, seat belts and shoulder harnesses on and tight. You want to do a soft field type landing with the tail slightly low. Ignition switch goes to the off position and brakes as required. Opening the door prior to landing, this will prevent the door from locking up should the hull buckle. So you should open up both doors on both sides. The airstream will keep the door flush. Again, precautionary landing items. The ELT will operate on 121.5 or 406 with the newer versions and can be activated prior to landing with the switch. Try to provide location to air traffic control, and they will relay that to the Civil Air Patrol. So notify ATC. You're squawking 7700 in your transponder. Mayday will be 121.5 if needed. Activate the ELT on the way down. Brief your passengers and secure seatbelts. The 172 is not certified for flight into icing conditions. So if the ice covers the static port located on the left cowl and the pitot tube, the pilot will lose instrumentation and could have false readings on his instrument panel. The checklist reads: alternate static source pull on. If the alternate static source is not installed, you break the glass on the vertical speed indicator. Consult for calibration changes in your manual. The checklist is complete. Now the pilot would also put on his pitot heat encountering ice. So the pilot would pull the alternate static source out and break the glass. You would break the glass on the far right side of the vertical speed indicator. You could do this with a small pocket knife or screwdriver, making a small hole. Don't break the glass on top of the needle, since that would prevent the needle from working. The pitot system is designed to provide heat to the pitot tube, which would melt the ice, and provide an alternate static source should the static port get clogged up with ice on the left side of the engine cowling. If that's not completed, then you're going to have false readings on your three instruments there: the airspeed indicator, vertical speed indicator, and altimeter. There's instrument loss would be the airspeed indicator, the altimeter, and the vertical speed indicator. Use the backup equipment on your GPS for velocity, and you may have other equipment there in your digital backups. The vacuum pump is a gear-driven unit, and it's located on the back side of the engine. It is used to provide vacuum pressure for the attitude indicator and heading indicator. There is a relief valve should there be too much pressure in the system, an outflow valve, and also a filter. The three lines going to the instruments provide the pressure between typically 4.8 to 5.2 pounds per square inch in inches of mercury. Should too much pressure build up in the lines, then the relief valve will open up. The instruments that fail would be the attitude indicator and heading indicator. Pilots should avoid using flights into icing conditions by changing altitudes and direction of flight. Proceed to the nearest field as soon as possible. There are four types of ice include clear, rime, mixed, and freezing rain. Accumulations will cause higher stall speeds and forward CGs. The propeller will accumulate ice, and then you'll have a reduced thrust on the aircraft. The checklist reads inadvertent icing encounter, pitot heat on, altitude and heading adjust, cabin heat on, defroster outlets open, throttle forward, carburetor heat as required, mixture lean, land as soon as practical, execute, flaps up, forward slip as required for visibility, since your windshield mate may ice over. Airspeed 65 to 75, depending on the ice accumulation. Touchdown, level pitch attitude, checklist complete. So there's a photo of the vents on the top of the 172 cockpit panel. You would spread those apart, and you have them on the left and right side. There's your pitot heat and your carburetor heat and your temperature control for the defroster and cabin. Ditching at sea can occur, of course, if you lose an engine in flight over the water, large lakes, and flying out to the islands. This is a possibility that it could occur. You pitch for glide speed, don the life vest, and prepare for your raft to exit. You don't want to inflate the life vest until you're in the water. Set your ELT since it does not transmit underwater. The checklist reads transmit on Mayday 121.5, transponder you're squawking 7700. Heavy objects and baggage you might be able to jettison and secure on the way down. Seatbelts and harnesses tight. Approach high winds and heavy seas into the wind, approaching light winds and heavy swells parallel to the swells. Flaps 20 to 30, and if power is available, 55 knots, descending at about 300 feet per minute. If power is not available, airspeed 65 and glide into the wave. Door and latch prior to the touchdown. Touchdown, level pitch attitude, cushion for impact, and aircraft evacuate. Life vests and raft inflate, and checklist complete. So here you're going to find the description of this in the Airman's Information Manual. It will provide the details and suggested methods. Don't fly into the wave, since the plane will flip upside down, and you'll be filling in with water as you're upside down. So try to keep the airplane on top of the wave. You can see that the lower right diagram, that's the poor entry into the wave, where the one on the left is like a surfer on the back side of the wave. With the landing parallel to the major swell, the top wave is the best. You should not take off with worn tires. Fog on the runway could cause a blown tire. Land on the good tire first and hold it off as long as possible, and then land on the blown tire. The checklist reads, landing with a flat tire on the main, approach normal speed, flaps as required. Touchdown on the good tire first, holding the broken tire off as long as possible. Maintain directional control, checklist complete. If you see the Kevlar layer showing through the tire, it's unfit for service. This is usually a situation when the pilot brakes too hard on the tire and the tire flattens. With a damaged tire, you can expect an increase in hydroplaning with worn tires. Normal hydroplaning with a good tire is going to occur near 55 knots. With a worn tire, the hydroplaning can occur sooner. The tire inspection prior to takeoff should include groove depth, pressure, and check the Kevlar to see if it's showing through. With skirts on the aircraft, you need to move the airplane back and forth to show the surface. This scenario can occur if you have a damaged voltage regulator. The checklist reads, ammeter shows excessive rate of charge. So the alternator switch goes off, alternator circuit breaker pull, non-essential equipment off, and land as soon as possible. Checklist complete. So using the time method, typically the 30 minutes of battery life will be available on the battery. The bullets here, the amperage needle will show high rate and stay high, or turn off the alternator rocker arm on the red switch, pull the alternator circuit breaker, turn off the non-essential radios and lighting, and you can expect about 30 minutes of battery, so land as soon as practical. So there you can identify the excessive amperage on the amp gauge, and you go to your battery master switch. There's your alternate field circuit breaker, and you're going to be pulling that out. So this checklist, low voltage light on, ammeter indicates a discharge. The avionics switch goes off the alternator circuit breaker checked in, battery master switch off both sides, battery master switch on, then low voltage light checked off, avionics switch on. If the low voltage light illuminates, alternator switch off, non-essential radio and electrical equipment off, and land as soon as practical. Execute. Checklist complete. So this scenario, typically you have a broken alternator. It could be a belt, alternator belt, which is located directly behind the propeller, is broken, or a diode within the alternator has failed. So the bullets read the red low voltage light will be on. The ampermeter needle will show a discharge. It'll be going to the left of center. The avionics switch goes off, and check that the alternator circuit breaker is in. Battery master switch off both sides, then battery master switch on both sides. Low voltage light should be off, and if it's on, then the alternator switch goes to off. Non-essential radios and lights off at that point, and then land as soon as possible. You're going to have about 30 minutes of battery. So there's the avionics switch goes off. You're checking that circuit breaker. That's the alt field circuit breaker. You're recycling your switch, and that light should go out, the red light. If the light stays on, you have a broken alternator or a broken belt. And here's that position where you're going to cycle that switch to do that. Radio failure troubleshooting. If you have radios that don't work, check your headset jacks. You have 3 volume controls on the headset, on the intercom, and on the radio. Check your radio circuit breakers that they're in. Check the radio frequency, then try another one. Check the radio volume, your squelch knobs. You can alternate between radio COM1, COM2, and if you have a COM3. Use your handheld mic or a handheld unit. And then squawk 7600 if your transponder has failed. You can use a remote radio frequency through a VOR. In this case, at Bangor, Maine, there is a remote transmitter through the Bangor, Maine flight service station through the Augusta VOR 111.4. And you can locate the nearest VOR. If it has that R in the frequency, then you can communicate through the VOR, but you do need to turn the volume up on that VOR to do that. And you can report to the flight service station and tell them you have a problem, and this way you can coordinate your situation. The transponder goes to 7600. If you approach a towered control field, the tower has to recognize that you have a radio failure. To do that, you overfly the tower pattern area to 1,500 feet, rock your wings, and flash your landing lights. Observe the windsock and traffic flow, and enter downwind at a 45-degree angle. On final, you can expect a landing light. Here, the landing lights are typically the size of a stage light, and they move on a track. So the tower controller will aim that at your aircraft to give you a signal to land. The signals can be studied on FAR 91.125, and they're either going to be landing or on the ground signals. So a steady green light on final would mean that you're cleared to land, where flashing green is going to be returned for landing, followed by a steady green. If you see a steady red, give way to another aircraft and continue circling. If you see a flashing red, then the airport is unsafe, don't land. Flashing white is not applicable in flight, but it is on the ground and it designates return to the starting point. If you see red and green flashing lights, exercise extreme caution. On the ground, a steady green is cleared for takeoff, a flashing green, cleared to taxi, a steady red, stop, flashing red, taxi clear of the runway, in use, flashing white, return to the starting point at the airport, and alternating red and green, exercise extreme caution. If you're IFR, you're going to squawk 7600 if you're unable to reconfigure your radios. On the route, you want to fly by the last assigned ATC route or by directed route from the point of radio failure to the fixed route or airway specified in the radar vector. In the absence of an assigned route, by the route that ATC has advised you may expect. In the absence of an assigned route or route that ATC has expected, by the route filed in the flight plan. With altitude, the altitude of flight level assigned in the last ATC clearance, the minimum flight level as per 91-121 Charlie, or the altitude or flight level ATC has advised may be expected in a future clearance. So you do want to look at your minimum en-route altitudes, minimum crossing altitudes, etc. on your maps. Leaving a clearance limit, when the clearance limit fixed from which a airport begins, commence the descent or descend and approach as close as possible to the expected further clearance time if one has been received. Or if one has not been received, as close as possible to your ETA, estimated time of arrival, as calculated from the filed or amended estimated time and route. If the clearance limit is not affixed from which the approach begins, leave the approach limit at the expected further clearance time if one has been received, or if none has been received upon arrival over the clearance limit, and proceed to a fix from which the approach begins and commence the descent and approach as close as possible to your ETA as calculated from the field or amended estimated time and route. The Cessna 172 does not have a standard electrical trim package, but they can be added on afterwards. If the pilot does have one, he should be able to determine how to disconnect it prior to flight. Most units have a disconnect button. Also, a circuit breaker can be used to disconnect them. If they are wired into the avionics bus, they can be isolated by turning off the avionics switch. Doing so will also cause the digital data for navigation to disappear. So pre-flight of the trim system is required. Most systems have a disconnect button as shown on this lower picture with the red button. If the system has a circuit breaker, check the position. The runaway trim, press the disconnect button. If it doesn't work, pull the circuit breaker. Autopilot failure has occurred and is dangerous at low altitudes as well as with the trim. So pre-flight of the autopilot system is required. Most systems have a disconnect button. If the system has a circuit breaker, you can break the electrical current to it by pulling it. Press the disconnect button, pull the circuit breaker if the disconnect fails. The master switch can disable the autopilot but render all electrical equipment inoperative. So be aware that low altitudes with autopilot failures can be very dangerous. Emergency equipment falls under 91.509, 91.513. You should have a workable ELT on board. Over water, you need survival equipment. Over 50 nautical miles or 30 minutes or 100 nautical miles. Beyond gliding distance, you should have life vests. Additional equipment includes fire extinguishers, carbon monoxide detectors, six-sack and Dramamine, and first aid kits. The ELT, emergency locator, is typically located in behind the baggage area or in the empennage area of the 172. The ELT transmits on emergency frequencies of 121.5 and 243 megahertz. The newer systems also transmit on 406. The 243 megahertz would be a military aircraft. You can test these ELT systems 5 minutes past the hour with the tower's approval on frequency 121.5 to monitor it and press the on switch position. The life vests, life rafts, and portable ELTs and signaling devices should be available on board the aircraft if you're going over water. The life vests should have a light. They're inflated via a blow tube and a lanyard, which can inflate them with the CO2 cartridge. The raft, same thing, has a lanyard which you pull, which inflates the raft. If you have 4 people on board, you should have a raft that fits 4. If you have 6 people on board, same thing. Fire extinguishers can be installed in a location that the pilot can reach to and get a hold of. Again, you take the clamp off, pull the pin, aim it at the base of the fire, and squeeze the trigger. Don't breathe the fumes. Carbon monoxide detectors will give you an indication if you have carbon monoxide in the cabin, and they're manufactured to detect parts per million. If they turn dark, turn off your heater as soon as possible, ventilate the cabin. They're typically located on the panel. You should put them at eye height if you're installing them. Put your expiration date on them. And in your scan, always look over there to see if they're darkened. Close the heater if they are darkened. Open up the vents for the pilot and passenger side. Open up the side windows and ventilate. Land as soon as possible. Medical assistance may be required depending on the parts per million of carbon monoxide. And carbon monoxide is identified as CO in the atomic weights. Warning, carbon monoxide can cause unconsciousness and death. Detection is important, so replace the detectors periodically and put the dates on them when they expire. Carry some six-sacks with you and motion pills. Dramamine should not be used by the pilots, but can be given to the passengers to calm them down. If you run into turbulence, slow the plane down and provide the six-sack for the passenger if they're nauseated. Aviation first aid kits are available, and you could put them in the baggage area. They provide bandages, gauze, disinfectants, and typically they don't have tourniquets, so you might have to create a tourniquet out of your belt or your seat belt if you have a major cut. NTSB requires reports if there's a system malfunction, flight crew member is injured or ill, in-flight fire, aircraft collision, or damages exceeding $25,000. This can be found in Part 830 in the Airman's Information Manual. Carbon dioxide detectors are available through my website at $5.95 each. If you need to notify me, I have a website link here, flight training at aerospace.com. Have a good day.